I would be keeping everything that I give you whenever I give you a quiz back and stuff like that.
Where are we at?
You skipped one. How dare thee?
The bottom of ours.
Okay.
Okay, I'm just going off. That's it. Yeah, but look how crappy it looks. Okay.
Because you got cut off badly. Again.
Continuity. Before, tell me how we defined continuous before.
It goes on and on.
You don't have to lift your pencil, okay? That was our basic definition of continuity. Well, now, just like with limits, how do you prove that a limit exists?
You find where it leads.
So what do you have to show? The same what? Both sides. The left-hand limit has to equal the right-hand limit, yes? That's how we prove that a limit exists at a certain point, right?
Hold on a moment.
So with continuity, we also have to show several things. There are 3 criteria to show that a function is continuous at a point C. And we're looking at those points in piecewise where we break apart, right? And you've really already done this. You just didn't know that that's what you were doing. All right, the first thing is I have to be defined. What do I mean by defined? If I plug that value in, I'm not getting a 0 in the denominator. I'm not getting a negative number under a radical. I'm getting a defined function, okay? The second thing is the limit as x approaches that value must exist. Well, we know in order for it to exist, that means that the limit as x approaches c from the left has to equal the limit as x approaches c from the right. And then the last thing is the limit as x approaches c altogether has to equal the function value at c. So this is a whole lot of gobbledygook that I am going to condense down to one equation for you because this is what you'll show. I'll give y'all a second. Yep. Define means you don't get a 0 in the bottom. You don't get a negative under a radical. Say again. That's just plugging in. That's saying that what you. I'll show you an example. Yes. What kind of class pet would you like?
Can we get a youngster? No. I want a duck.
Our ducks, we don't have very good luck with ducks in the tea house now.
Then we need a hamster. We get a hamster. We get a hamster.
Hold on.
Let's kill this duck. Let's kill this duck.
If I buy the hamster, we have it.
We have a duck set. Yes.
Yes, that works.
Star this, highlight it, do whatever you need to do because you will be asked multiple times, is the function continuous at C? And this is what you have to show. If you can show that the limit from the left equals the limit from the right also equals the function value, you can say that the function is continuous. That's what it means to be continuous. So this is your big takeaway, not the whole, oh, what is going on? I got it. All right.
It's a little hard to pay up.
So let's look at it on a graph, okay? Y'all got that?
Whoa, hey. I've been writing it. I don't write that way.
While y'all copy that, I'm gonna keep going here. The first one, this is an example of one graphically that you can see. F of C is not defined. There's a hole here, right? Not continuous. Here. This one, the limit from the left does not equal the limit from the right, therefore it's not continuous. They're not, but it's showing you all the different ways and how you can apply those three. Remember, this is what you're looking here. It's not defined, and it doesn't equal what is defined, but f of, yeah. The limit doesn't equal the function value. The function value is different.
Technically there is.
So because the left-hand limit does not equal the right-hand limit, it's not continuous. Y'all see that? Do y'all see all the different scenarios? Okay, let's keep going then. Let's look at an example of what this would look like on the exam, because this does show up. I promise you, I would be willing to, I'm not going to promise, I'd be willing to bet that by the end of the semester or the end of the year, you will like the non-calculator ones better than the calculator ones. Well, look who decided to join us this morning. Did she?
No, she has to take it right now. Sit down right there.
Don't. All right.
Why do you have that shirt?
These will almost always. Okay, these will almost always be a piecewise function this way. So what it's asking us is it's saying, notice that part that's saying show that it's continuous at x equals 1. Or x equals 0.
Move back.
The whole time?
Throw it even.
I missed this before. So show that it's continuous at 0, yes? So I need to show three things. I need to show the limit as x approaches 0 from the left. I need to show the limit as x approaches 0 from the right. And I also need to show f of 0. Three things. Right?
I use 5 days to 6.
Three things. All right, limit as I approach from the left. How do I do that? How do I go from the left?
Plug in the 0.
Which one?
The bottom.
The first one from the left. Less than is left. Less than is left.
Sign of 0 is 0.
And we hope that we can just plug in and don't have to do an algebraic manipulation, right? That's what we've been talking about. Sine of 0 is 0, so this just gives me 1. How about the right-hand limit?
Wait, what?
Well, it'll be 1 minus 0.
E of 0. E of 0.
2 times 0. E to the, what is that exponent? Negative 4. E to the 0, which is... Now, f of 0. What in the world is f of 0? Well, this is when it includes 0, right? So it's 1. So I would say, therefore, that means therefore. Therefore, since the limit is x approaches 0 from the left, equals, yeah, the limit is x approaches 0 from the right, yeah, which equals f of x is continuous. You would have to show, you could show that
Therefore, in front of a word, and say f of x.
9 times out of 10, as long as you show each of these, as long as you have showed the right-hand limit, the left-hand limit, and the function value. It's just a good habit to be into, but yeah, you could show. Because this is the one that includes 0, so if I were to find the function value there, I would plug in here. What would make this not continuous would be if this one was x is less than 0, and maybe I came up here and said f of x equals 3 when x equals 0. Now this is not a continuous function because I plugged the hole up above it instead of. That's correct, yeah. There'd be a hole there.
So if that ever happens,
But you would say, because the limit as x approaches 0 does not equal f of 0, the function's not continuous. There wouldn't be a lot to say that, but you'd need that sentence justifying that, because the limit. I'm not going to go through this whole chart. Y'all already know this. What are the types of discontinuities that we a hole is the graphical. Jump is also and asymptote. You're exactly right. That one. What kind of discontinuity is a hole? We said this earlier. Removable. How about a jump? Also removable? Non-removable.
Infinite.
How about an asymptote?
Maybe you should put a hole in the bottom.
Well, these are your choices over here, essentially, is what you're. The point is you can fix a hole. You can't fix an asymptote or a jump. It is an infinite, but now that we're in calculus, we're calling removable. But the point that I'm getting at, removable means I can take it out, I can plug the hole, I can fix the discontinuity. I can't fix the discontinuity on a jump or an asymptote. Yeah. Or pre-calculus. Okay.
That's too bad.
Let's keep it going. Look at the example here. I'm not going to spend a long time if you guys understand this because you don't. Okay. Okay. We are looking for discontinuities, right? Holes, jumps, asymptotes. So if you're looking at the graph, yes, but we're specifically where I see everybody held up. Look at example 3. Let's jump down to example 3. Determine all, yes I am, it's recording now. Determine all values. And I want to do example 3 and example 4 and then I'll stop. All right. Yeah. It was a 15-minute limit. I recorded the first 15 minutes, then it cut me off. But consider the piecewise function defined below. Determine all values where h of x is discontinuous and classify as removable or non-removable. So where are my possible discontinuities? -2, 1, and 3.
Yes.
Somebody grab that. These are possible points of discontinuity. Because this is the part, these are all continuous functions. These are the parts where they break. Possibly break, right? Because that's so, start plugging them in and checking. Remember, we want the points to be the same for each one, because that's going to show me that my limit is. Okay. Because it's 9:15, I need to do this. Okay, so we're checking these points, right? We're plugging each one of them in because what I want to know is, I want to know if these points Is it the same point on each graph, or is it jumping up to something else, or is there a hole created somewhere, right? So say right, because that was right. Okay. At -2 on this first graph, right? -2, I get -5. Do we all agree? Whoa. All right. On this second one, if I'm plugging in, I'm going to plug in -2 first, because at -2, I want to get -5, right? So at -2, I do get -5. So what I'm looking at here is that this is continuous at -2, right? Because it matches up on both of those functions. Does that make sense to everybody?
You have to plug in.
The left-hand limit equals the right-hand limit, which also equals the function value at -2. So it's continuous at -2. I only do that point because this is where they're breaking right here. Okay. Now for the next one. So watch what happens for the next one. If I plug in 1 for this one, I get -8. I'm plugging in these constraints. Okay, so now if I plug in 1 to this one, because that's where it's jumping to the next function, I get 5. So what's happening here is this it's a jump, it's a non-removable, because a jump is a non-removable. So this is a jump.
Wait, number 3 is already a discontinuous.
So a hole is only going to happen if you get the same value. Look, you know how we talked about there's no line under there? It's not included, and you said, well, that would mean it's a hole there. That's exactly what that means. That's a hole.
It's already a discontinuous.
All right, so at 1,5, so this is a jump, so it's non-removable. We'd have to look to see if there's a bottom that goes to 0. That's the only way those vertical asymptotes are happening. Okay, so because these are different points and going off in different directions, that's how I know it's a jump. You've got 3 possibilities: a jump, a hole, and a vertical asymptote. Okay, I'm fixing to show you the hole and you'll see. All right. All right, Sullivan says 3 is continuous. If I plug in 3 here, sorry. I get the same thing. So that's telling me the left-hand limit equals the right-hand limit, right? But that's not all continuity needs to show. Function value. What's the function value at 3? Uh-oh, I'm not defined at 3. So there's a hole there. So this is a hole, so it's a removable discontinuity.
I think you missed.
I think we got this one.
Oh wait, she missed the part. For a hole, for a point to be continuous, it needs to the limit has to be defined and the function value.
It's it. Jumps are whenever it goes to 2 separate values. Okay, so if you get something like this, that's a jump. A hole means it's undefined at that point, just at that one point. Vertical asymptote, bottom equals 0.
It's like if one of those had a, like one of those is like right there.
Say that again.
Like say the bottom says X is greater than X is greater than.
Then it would be continuous. Yes. Did y'all hear Emma's question? If that bottom had been,
Probably right.
so if this had a, all right guys, if this had a line under it, if this included 3, it would be continuous.
Yeah.
Or above it, either one. If that function was defined at that point, it would be continuous. All right, I want y'all, while the homework's coming around, I want you to look at table 4 because I do want to go over that with you, because this This is like the exam. This is what exam questions look like all day long with the A's and B's.
Now we have to actually do math.
This is when they really test to see, do you know what continuity means?
How do we write out those different? Yeah, but Sullivan dumb verbatim the entire thing. It could be alive.
I would have done it too.
Well, I kept it when she went out of town and she left it at my house.
Bro, what are you talking about?
Somebody ran my screen.
How do
They're not replacing all, but look at what it's asking. Find the values that make it continuous everywhere, using those definitions of continuity. Yes, yes. Well, no, you don't necessarily have to write them out, but it's saying, I know, guys,
Can y'all be quiet?
this is the part I need you on. This is the hard part of this, okay? The continuity definitions are easy. It's hard to apply it, all right? This is about the time y'all just lose control. All right. What you mean? You don't have to write that for that. No. So they're telling you, right. They're telling you, I want it to be continuous. So you have to apply what you know about continuity. I know that at 2, if I plug 2 in for x to both of these, I better get the same value, right? Does that make sense? So here, if I plug 2 in here, 2 squared minus 4 over. Oh, so what do I need to do?
The problem is with the next.
All right, so when I plug in here, I get 4. I need 4 to, well, that's what I've got to solve for, right? I need 4 to equal 4a plus 2b. Well, I'm going to have to use that equation. All right, watch. This is why y'all got to pay attention. When I plug this in for x, I need to get the same thing as when I plug in x here, right? I've got this equation. I have 2 unknowns. I don't know what to do, so I'm going to move on to the next thing. I also know that when I plug 3 in here, I better get what happens when I plug 3 in here, right? So 3 in here would be 9a plus 3b plus 3, and that better equal 6 minus a plus b. This is the continuity at 3. This is the continuity at 2. Okay? These are 2 different equations. I have to find A and B, y'all. Gross. I've got a system of equations here is what I have.
Where'd you get the 6 minus a plus? That's the bottom one. I thought you did the bottom one first.
We're going to clean them up as much as we can, and we're going to solve. So here, I'm probably going to solve one of these for A and plug it into the other one. I always did. Do y'all remember substitution and elimination whenever you? Gross. I always do substitution, though. I'm probably going to get everything together here. Add the A, subtract the B, subtract the 6. 10A plus 4B minus 3. However, if you're an elimination person, eliminate away. You can multiply that first one by -2. Add them together. Yeah, sorry. All right, I'm going to